What is up, everybody? You are watching NASA in Silicon Valley Live for Thursday, September 27th, 2018. I am one of your hosts, Matthew Buffington, and today we have a special guest host. He is a YouTuber, a Twitch streamer, a professional Scotsman, and all-around cool guy, Mr. Scott Manley.
Hello!
How's it going, Scott?
It's going great. Glad to be here.
Are you hyped to do the...
I am as hyped as you can get to be playing with rockets, yes.
Yes. So for folks, if you don't remember, folks who were watching the show, about, I think it was in January, we did a NASA Silicon Valley Live show. We did our first space video game show. And so as we were sitting there playing the game, Scott was actually in the chat. And so as we're sitting there going back and forth on Lunar Lander, it was another one. What was the other game that you brought? It was not Lunar Lander.
Space War.
Space War. He was saying like, hey, you got to lead your shots. You got to jump on in. So
That was you?
that was...
Among other things,
Everyone's
yes.
a critic.
So it was like, so as we were going through, we went back and forth on Twitter a little bit, and I was like, well, hey, let's bring Scott on over to come and help host this show. So welcome.
Thank you.
So our returning Jeopardy champions, we have Mr. Chad Frost and Mary Beth Wilhelm. How are you guys doing?
Great.
Hanging in.
So what anything new happening since the last time you were here playing video games with everybody? What's up? I know, Mary Beth, you just did a presentation, right?
Yeah. We're working on developing some new life detection technologies, and I did some field work in Iceland and lots of lab work. So it's been a busy summer. I'm ready for a vacation.
I think you just came from the presentation, and Chad, you were one of the
Chad
judges.
was our evaluator. So.
How'd you do?
Oh, they're awesome. Yeah. I mean, they're actually doing their big presentation in about a month, so this was our opportunity to give them a little feedback, and fantastic ideas coming out from all directions. It was super cool.
Awesome. Well, so for this episode, folks, if you can't tell, this is a special Let's Play Video Games episode. But let me jump into the rigmarole, because if you didn't know, this is NASA in Silicon Valley Live, a conversational show out of NASA's Ames Research Center, where we talk to researchers, scientists, engineers, and all-around cool people about all the nerdy NASA news you need to know about. So if you like that, we are live on YouTube, Facebook, Periscope, Twitch. If you want to participate live in the chat, just like that lower third says, you need to go to twitch.tv/NASA. And our friend Kayvon back behind the scenes is actually digging through those questions, so I don't have to see the constant deluge of stuff in the chat. But if you can't catch us live, that is no big deal. We will have video on demand on Twitch and YouTube immediately once the show is over. And the next week it'll be up and replaying or rebroadcasting over on NASA TV, and also we'll have it on an audio version for podcast services throughout the solar system and beyond. So, all right, so before we start moving along, folks who are in the chat, start sending in those questions now. There's different parts throughout the show. We're just going to keep jumping in and grabbing questions from everybody. But, since we are doing video games, I have to make our legal friends a little bit happy. So we're going to jump into a fun disclaimer. We have a fun disclaimer over underlay, or I guess lower third. So this is just to remind everybody as we're playing these games that NASA does not promote. There we go. There it is. NASA does not promote or endorse, or will it provide the appearance of that NASA promotes or endorses a commercial product, service, or activity. Individuals that playing specific games does not constitute an endorsement of such games by NASA or the U.S. federal government. So, then with that, we're going to go jump on into some of our first games. But you know what? We did this cool segment transition, so we might as well just play that on over that we're doing for every episode. So. Of course, it's time for a Let's Play. Now, this can include controllers, 12-sided dice, or a Pop-O-Matic bubble. But for this episode, we are playing video games. So, Scott, what do you have for us first?
Well, I came up with a huge list of NASA-related games.
I saw
it. Obviously, we're going to play a few of these, but the first one that I wanted was Elite Dangerous.
Nice.
Which is basically a space sim set 1,000 years in the future. And not only can you fly a spaceship, but the game includes renderings of the entire galaxy. So you can go anywhere in the galaxy, including a few places that NASA has actually sent spacecraft.
Nice.
So yeah, this is a Elite. I think we can't play it live because we need an internet connection, but we do have a highlight reel of some of my favorite things.
So what are we looking at and what are we seeing here?
We are flying towards Charon and Pluto, which are the two most distant explored bodies in the solar system.
And how fast are we going?
It looks like 1.5 times the speed of light.
Very nice.
You know, whatever.
It's 1,000 years in the future. We'll take some liberties.
Yeah, we're having to slow down a bit so that we don't fly past them too fast.
And so let's talk a little bit about that. I mean, because obviously, being here over at Ames, we're familiar with the New Horizons spacecraft as it went through. It did the whole flyby of Pluto, got some really cool photos, and now it's heading up to another body. I'm trying to remember.
MU-49, I believe, also called Ultima Thule,
Okay.
and that'll be the last day of the year when it's doing that, pretty much. So you can see we're coming down. There's Charon and Pluto next to each other. So the developers of this game try to incorporate as much reality as possible. So they took textures from the real Pluto and Charon and mapped them onto this. You can't land on Pluto, but we will be able to get closer to Charon. I'm just looking around in the cockpit here.
Yeah.
It's of course, like, you can't talk about Pluto without the first thing in chat being like, is Pluto a planet? That's Tress.
It's a dwarf planet.
It's still a
Tress or
planet.
Gret.
It's just a dwarf planet.
So it's still a planet.
It's still a planet.
It's the
just
only binary planet. It's a pretty cool planet, if you ask me.
Yeah, and Charon's a really cool moon. Like, one of the big discoveries from New Horizons was that on the North Pole, there's a deposit of these compounds called tholins. It's like this kind of reddish material, and what that is a mixture of organics. And Pluto doesn't. I don't think Pluto has those deposits, but Charon does, which is pretty neat.
Now, is this Pluto or is this Charon?
This is Charon because
Is that those
Oh
things?
yeah, see, there's the reddish material.
yeah,
There's the
and
tholins.
I wanted to fly through some of these canyons that we saw. Chasmata. There's 7 of them that have been named on Charon. They're all named after fictional spacecraft. I can't remember which one's which now, but I think only 3 have been approved by the IAU because they're from mythology. But we've got things like TARDIS, Chasmata, and Nostromo.
No way.
Serenity. I don't know which one this is I'm flying through, but I am, trying to do my best Beggar's Canyon impersonation here.
Nice.
I'm really digging the cockpit here. This is
It's so much better in VR when you can look around and see everything. This is one of the best things to have in VR. This.
And I was going to say, so for Chad as our director of engineering or acting director of engineering here at Ames, it's like, what would you give for a cockpit like this?
a lot. Yeah, this is. It's easy to forget that it's supposedly 1,000 years in the future, right? Because a lot of the concepts and ideas that we've been working on sort of play into that same general look and feel, and yet. If you do it right, maybe that's what they'll use 1,000 years hence. But I love it's got a little map of the solar system down there, tells you where you are and how to navigate. There's some terrain shows up in there. This is the first time I've ever seen this particular game. It's it's kind of interesting to find your way around in there visually and see what's going on.
In the game, there's something that you might remember from the past here. We're actually coming up to an ancient space probe.
The ancient space probe.
Voyager.
Yes. And I don't know if you can hear the audio.
I think Eric's going to pump up the audio for the audience so that they can hear that. But as we start getting closer. Oh yeah, listen to that.
As you may...
Because right now, where is Voyager right now? Because this isn't where Voyager is right now. This is where Voyager will be in 1,000 years in the future, right?
Yeah, this is like... I don't know how far out it is, like 80. It's left the solar system, technically. It's crossed the heliopause into interstellar space.
It's the only man-made object ever to do so.
Yeah. But I brought along an interesting prop. I don't know if we can
I know,
show
we can
this.
do the picture-in-picture
Awesome.
so we can
have
get some of our prop stuff over
a
here.
reprint, a repressing of the Voyager Golden Record. This was done last year, and in the inside they have all the music, and they
Really?
have the sounds, the greetings from the various parts of the world. And my favorite part, being a DJ, is a slip mat showing the trajectory that Voyager took on the way, the two Voyagers took. So yes,
That's really
And of
cool.
course,
That's a
and it
pretty
had to do like gravity assists, whipping past different
it did.
planets.
Yeah, 3 gravity assists. Well,
Grand
Voyager
Tour.
2 did.
But we should talk about like what it was. It was a record that was put together to represent all of the sounds of the Earth. And the very first part of the record is recordings of I think like over 50 languages greetings, and then it goes into like the best music from all over the globe was compiled and put onto this record and affixed onto the front of the spacecraft. And in about let's see, tens to hundreds of thousands of years, the Voyagers will pass by nearby stars. So the idea is someday maybe somebody will find it and be able to listen to the sounds of Earth.
Well, as the engineer, I always was thrilled that right on the surface of the record, it tells whoever might find the record basically what a record is and how to get the information back off of it, right? So it says, look, there's sound waves on here, and this is what they look like, and here's what you need to do to play the thing back. Plus other basic information content, but starting with, hey, here's what this artifact is and what you might do with it to get at the information contained.
Get some nice.
And so before we jump over to the next one, somebody named Silent Searchlight said at NASA, have either of the Voyager probes traveled beyond the outermost radius of the Oort cloud yet? Oort?
No, the Oort cloud goes way
No.
further out. It goes out to 100,000 AU or beyond.
So there you go, Silent Searchlight.
I know Silent Searchlight. Yes.
So they're on their way, but it'll take, a long time for them to get out that far.
And so, okay, so what are we looking at coming up over here?
We're just continuing on our journey. We flew past the sun, past Parker Solar Probe, but we're going to go to the moon. And I know NASA's talking about a space station around the moon. Well, we have a space station around the moon 1,000 years in the future in this fictional universe. It's a little bit bigger than what NASA has in mind.
Okay.
This is called Galileo, but I just wanted to show the docking sequence in this game because it's
pretty cool.
It is pretty cool. Obviously takes some inspiration from 2001 here. This is the Galileo spacecraft. Space station. And you need to request docking permission from the space traffic control. It's a future where they don't have magical artificial gravity, so for most people to get gravity, they have to rotate the station, which means you have to match the rotation.
It's very realistic.
It's realistic in that way, but
of course, there's already like billboards and
space
commercials.
advertising. NASA does not endorse any of those.
No, NASA does not endorse or appear to promote or endorse any of the space advertising. Did I see something that said Titan City?
Yeah, there's a Titan City. You can go there if you like.
What is Titan City?
It's another space station in orbit around Titan.
Oh, Titan's cool.
There's probably cities on the surface of Titan, but you can't land there right now because the game only lets you land on planets with no atmosphere. Which is a shame because Titan is a fantastic place to visit with lots of atmosphere.
I think it's the only other place in the solar system where it actually rains.
Really?
Yeah, it rains liquid ethane and methane, though.
Yeah, at least with a solid surface. I think there's possibility of rains in some of the gas giants, but yeah.
My experience with Titan has been playing in Destiny 2. They have Titan and they have these like oceans. It's basically went from a frozen planet to ocean worlds. And the only time I'm sitting there, they'll have like somebody who you talk to and they have their helmet off and they're just like chatting with you. And I'm like,
now wait a minute.
It would be pretty cold.
Wouldn't it be pretty cold? And even if
just
it's
70
like
Kelvin, it's fine.
it's like even if it's like, okay, so the methane isn't frozen, but it's liquid oceans of methane, it's still gonna be pretty cold outside.
Pretty cool. So anyway, yeah, I guess next point after stopping to get some coffee, time to head out into the outer solar system. Taking a look around as well. Yeah, people love their greenhouses. There's other spaceships, obviously. I'm going to point out that while this game does let you shoot other people, and it's a big part of the game, during this sequence I decided to be totally a pacifist. Don't even have guns in my spaceship.
No, nice.
And there are aliens who... Well,
looking through the chat, a lot of shout outs to Scott.
Hello!
So, hello, everybody. And then there was another person who was, I think, Captain II is asking what timeline is this? He said, what, about 1,000 years in the future?
About 1,000 years in the future. And has real time that advances in March with our own time. So it's, September 27th in whatever year it is.
And so I don't know, like Chad, as somebody who, as an engineer, like talk a little bit about like what are some of those complications to actually build these things. I mean, we're way far off, but it's like there's a lot of stuff we have to figure out before anything even comes close.
Yeah, absolutely, right. And some of it we're starting to work on and figure out. One of the big questions is if you want to build something really big in space, just how do you do that? Well, the biggest thing we've ever built in space is the International Space Station. By and large, we built that by sending all the pieces up as modules and assembling them on orbit with a lot of human labor. Right? It's mostly astronauts putting things together in space. And you could do it that way, but if you're talking a space station the size of this,
it's going to be
there's a huge human labor problem, or alien labor, as the case may be. And so we've really been putting a lot of effort into figuring out how do you do this robotically, so that you can have the robots go do it.
The robots can deal with the cold weather.
Send up the raw material, let the robots put it all together. We'll show up and live and take advantage of that.
Well, and that's one of the cool things that we've talked a lot about, like on the journey to Mars. I've talked about going to Mars and talking about the moon. I was like, there's a lot of stuff about like humans living in deep space that we still have to figure out. And like, a cool thing about being at the moon is like, if something goes wrong, you're not 2 years away. You can try to get back a little bit sooner. So
yeah, if you're far away, right, even as far as the moon, you have to take a lot of those things that we take for granted here on Earth. You have to take them with you. Right? Whether it's raw material resources, whether it's consumables, whether it's water, oxygen, food, all of those things that we just sort of, hey, I have my mug of water right here. If I'm out there in a space station, it's not readily accessible as a natural resource. It's either stuff I took with me or stuff I'm making out of materials I took with me. It's kind of a closed system. That really puts a whole new load on the technology, on how we do it, and we're having to figure those things out all the time, whether it's on the International Space Station or the new Lunar Gateway or anything we want to go do. You have to figure out how to do it with the materials you've got that you took with you.
So going on in the background as I'm just sitting there going through, we just buzzed past.
We flew through the Saturn system just like Cassini, but we spent a little less time there than Cassini.
Yes, well, I guess Cassini's still there, or just like in many pieces, burnt up, but like its atoms are still present on Saturn, I'm sure.
And Huygens is still intact, so
So you have another landing base over here?
Yeah, because I wanted to get another spaceship with a little rover that I can actually go and visit the surface. We flew past Enceladus, Enceladus, which is a moon of Titan. A moon of Saturn, sorry.
Yeah. So, what is the proper? We were just talking about it. Of like, is it Enceladus, or how do?
I've heard it pronounced Enceladus, but I've heard it also pronounced the other way too.
Just depends on how you feel, how you're feeling.
I think it depends
Enchiladas.
on enchiladas.
Nice. We had the same conversation around like Sharon. Is it Sharon or Charon or Charon?
I actually looked it up. The moon Charon, it was named in part after the discoverer's wife, whose name was Charlene. So, I guess the community pronounces it Sharon after Charlene, but it's officially named after a mythological figure. So, and the correct way to pronounce it in that case is Charon, but in a scientific conference, you're not going to hear that pronunciation. Who was, I guess, that particular mythological figure was because Pluto is named after the Lord of the Underworld, but Charon was the ferryman that took people across the river. So it was like
the river Styx.
Yeah.
Yes.
He's not the Disney character.
No.
I'm so disappointed. I knew that.
Well,
yes. Yeah. So Scott, tell us about.
I know we're now heading over to Europa, which
we got to buzz by through Europa.
Recently, they found ice geysers there using data from Galileo and Voyager. Right? They found that there's actually cryovolcanism. Europa is obviously fascinating from an astrobiology standpoint because it's got this huge ocean, right?
Yeah, there's just beneath the surface there's a thick sheet of ice, a few kilometers, and then beneath it is a lot of water.
I know that Mary Beth can literally talk all day about astrobiology.
I could talk for at least a few hours.
Was that your whole presentation that you just did?
But yeah, it's kind of hard to imagine an ocean world like this because it's completely dark. So when we think of our Earth's oceans, we imagine light streaming in and beautiful green algae. But if life exists on Europa, it's living off of chemical energy and complete darkness. So it's a totally alien way to think about living.
Miss Anno Vent says, you guys ought to go to the geysers on Europa. I think we got you one better, right? Or-
We are at the geysers on Europa.
Is it Europa or is it the Enceladus one?
No, this is Europa.
this is
I went.
Europa.
Oh, so there you go.
This is a relatively new discovery, I think.
Yes, but it's based on old data,
Yeah.
which is always fascinating to find new discoveries in old data. So yeah, this is an ASP Explorer, much better cockpit. You can see a lot more there. So we just
that's
pause for a
beautiful.
beauty
That's gorgeous.
shot.
Nice.
Yes.
Gotta get the Vista shot.
That's right. That's Jupiter in the background
Look
there.
at all those free samples.
Exactly.
Should go pick them up.
Had to click
You
share.
know, actually, yeah, I'm gonna get out in my rover and go for a drive here.
All right, so let's check this out.
Yeah, I mean the game has had, volcanic fumaroles, weird alien fungi, alien archaeology. They're all things you can visit, but we're staying within the realms of reality at this point.
Yeah.
Although these geysers are a little more powerful than the ones in real life, I suspect.
Really? And so, in fact, when the recent discoveries of, the cool thing about these geysers, the idea is like they found what is it like the building blocks of life in those, or
On Enceladus,
on Enceladus,
which also has a geyser, which I think they're much larger.
Yeah.
So, yeah, talk a little bit about what that means for astrobiology for future NASA missions. What we're hoping to do.
Yeah,
and-
imagine how much easier it is just to fly through a plume and take a sample rather than have to land and drive around and,
Yes.
and collect sample as we're doing in this.
Or
in
drill
this
through
case.
many kilometers of ice.
Yeah, that's really hard to do on Earth, let alone on something that's that far away from Earth. But yeah, the samples themselves are really interesting because they've identified all of the raw ingredients needed for life in those plumes. So the hope is that we could send a more advanced type of instrument that could actually tell us if there is life contained within that sample. And I think that's going to be one of the most exciting missions, in my lifetime, certainly, trying to answer this question of, is there microbial life anywhere else in the solar system?
And remember, the material coming up out of those plumes is the material from down below that ice layer. And so we think if there's life to be found, it's down in that comparatively warm environment. And rather than having to drill down through the ice to get to it, hey, it's conveniently coming right up, right up through in the form of these geysers and these vents. And so we don't even have to land on the surface to collect those samples. We can just fly through them from above.
And so, one of the things I get a kick out of this game, especially, is the data that it uses is it's using real data,
It's
real
using
places.
real data. Yeah, this is.
In fact, the shot that we just had, that we can have
We should
Bill
rewind.
throwing up. Yeah, Bill, if you want to jump on back a little bit to that big shot of all the stars. Yeah, so this is real data taken
Yes,
from.
all of these stars are real stars. I mean, they start to fill in once they get too farther out, but many of these, or some of these, have been identified by NASA missions, such as WISE 8550714. Right, that was the Wide Field Infrared Survey Explorer. So they've obviously measured the colors and parallaxes and put these planets in place, but they've tried to extend this out to the entire galaxy, and you can go a long way out. You can travel to the core of the galaxy if you like and get to Sagittarius A star, the supermassive black hole in the middle. You see we've got Nebula, the California Nebula, Barnard's Loop, Polaris, obviously, pretty well-known star.
So I'm really curious if any of the exoplanets that have been discovered by our Kepler mission have found their way into the orbits around these stars.
Funny you should say that, because we are able to travel anywhere in the galaxy, and I might just pay a visit to one of those Keplers. So that's where we're going next. We've been traveling around.
We did not plan that, by the way.
So we've been traveling around at the speed of light, but using hyperspace, we can travel even faster.
Nice.
We can travel up to 2,000 times the speed of light, or we can cross 50 light years in a matter of seconds, because it's a game and you don't want people waiting around forever.
Yeah, that's not a fun time.
So we're heading to Kepler 42, which was one of the Kepler points. It was found, it was obviously in the field of view, and they found planets transiting. Several large hot Jupiters very close to this parent star.
Yeah, I remember talking to one of the NASA Kepler project scientists. The way that she had described it is you put your hand up into the air, and what your hand covers is basically the field of view of what Kepler was looking at. And all of the planets that it had confirmed, the exoplanets it confirmed, in just that little itty bitty space. And Tessa's even doing so much more than that.
Yeah, but Kepler kept it all pointing at the same place for months, weeks, years even. Tess is spending a little less time. So those are the 3 hot Jupiters. So those are based on the real, the data that's been returned. This, of course, does cause problems for the game because the recent, new data set, is it the Gaia mission, yes, they have changed many of the positions of the stars, the distances, and so the game hasn't decided to update. It's frozen its universe. But it did add, it added TRAPPIST, this TRAPPIST system.
Oh, nice.
So, yeah.
Nice.
But
Which is the closest star.
It's not the Proxima.
Okay.
Has a.
But it was the most. It was only like what, 4 light years away.
It's pretty close by and
close.
has a lot. Yeah.
And a lot of exoplanets.
Yes.
Well, the exciting thing is now from the results of Kepler and K2, amazingly, right, pretty much every star on average has at least 1 planet. And there's some stars that don't have any, and there's some stars that have a lot more. But on average, there's at least a planet for every star that's out there. And so you think about the billions and billions of stars, that's billions and billions of planets. And even if it's a small fraction of them that is anything remotely like Earth, that's still a huge, huge number. It's just exciting.
This is the part where Kayvon in the chat is going to put the hashtag more planets than stars.
That's a pretty wild paradigm shift. I mean, like, growing up there were only 8, and now it's 9, I guess. R.I.P. Pluto.
All right, that was actually okay. Let me give this shout out to Acid Rain 1876-9 said R.I.P. Pluto. So, but that was back earlier in the chat. So, let me throw in another quick one that they had. Somebody had asked about Dread Metis asked, do you have any idea about the temperature of the plumes IRL?
Oh yeah, sure. So the water and the plumes originate at the interface between the rocky surface and the ocean, and the temperatures at that point are, I think, like quite high, like 90 or 80 or 90 Celsius.
Oh, wow.
And then it's pretty interesting. So like at that interface there, you have like these silica nanoparticles starting to form, and the water then starts to make its way up. And then as it exits, obviously as it exits into space, it freezes. So like, I don't know exactly what the temperature is, but it's no longer in the liquid phase, it's in the ice phase. And so that creates a problem when you're trying to design a collector, because you have to then take that sample and then remelt it in order to pull out any potential, markers of life that you would be interested in analyzing.
So we're going to eventually get to the point. This is almost like wrapping up Elite Dangerous.
This is us at the end, more or less, yeah.
But
there's our beautiful spacecraft. It's named at NASA Ames.
Oh, do we get to buzz in the name?
I'm not sure if we zoom in on it.
Oh, nice.
Oh, we may have reached the end of the video itself.
You can sort of see it. It's right there.
Yes, NASA there, right on the
Ames.
side.
So I do want, as we're getting ready to transition over to a new game that's on the iPad that we have over here, I do want to give a shout out over to Eric, our audio guy, who's sitting over in the audio booth. Now, he was pushing really hard to get No Man's Sky in on this one.
I love that, but it's not really scientific.
So he'd gone in and had played a little bit of Elite Dangerous. So Eric, I don't know, do you have any questions, any things about you want to throw on over to Scott about Elite Dangerous? Because I know it's it's a pretty tough sim game. It's kind of hard to figure that out.
It's very hard in places for sure, but a lot of it is carried by the fact that it's so beautiful sitting around in your spaceship and looking at planets.
Yeah, I totally agree. Yeah, it was a lot of fun to play with and really cool to look at, but definitely a steep learning curve.
Yeah, and I think as a sound guy, you probably really appreciate the audio in that game.
Oh yeah, it's beautiful.
I want to try it out on the VR goggles now. It just looks like that would be a natural fit.
We were actually talking about that, about how cool it would be to actually have somebody with the VR headset and just actually today I ran by somebody who over on their desk, they had an HTC Vive, and I was this close to just pulling it in, but maybe that'll be for the next episode, folks. So, yeah, let's switch on over to the next thing that we have set up here through the magic of an HDMI cable to an iPad.
Yes. I came up with this idea during the last show. You were showing all these console games, you were showing PC games, but not everybody has PCs or consoles. Many people have phones, and there's a lot of actually really good simulation games for rocket simulation, essentially Kerbal Space Program clones that will run on mobile devices. I'm running on an iPad because it's better, but I've run this on an old 5S. So this is a space flight simulator, or space simulator. I'm just trying to build a little rocket here. We're just dragging the parts together.
And Mary Beth was launching stuff right before.
Yeah,
as we were,
that was-
screwing around.
Well, we can have a go on that if you like. But
And what are your mission requirements?
well, right now this is just in the sandbox, so I'm just I'm going to try and put something up and into space here. Ooh, got to find a big rocket. I think this is going to be way too big. So yeah, I mean, this simulates the physics. This is free in the basic mode, and then you can pay a little extra for an expansion. So it's actually really nice if you're interested in learning how rockets work.
You don't have to pay extra for the fuel?
You don't have to pay extra for the fuel. But, fuel is always the cheapest part of the rocket, right?
Yep.
Compared to everything else. Oh, that wasn't quite right. Well, whatever.
Well, I'll tell you what, while you're setting that up, we have a couple comments from the stream. One guy, Captain Quasar, asked for a 24-hour stream, please. So we'll see what we do. We normally aim for an hour, but we have some stuff in store for you, so we may go a little bit longer.
I think it would get really boring when we sleep.
You'd be surprised on what, over on Twitch. People, they'll watch it.
Yeah.
So, but here, let me throw this over to Chad, because he said, one question, comes from Maker BR. He said, what kind of engineer do you need to even be to consider getting a job at NASA? He says, I'm finishing as civil engineering, and I wonder if I can.
So amazingly, we have civil engineers at NASA, right? Because, hey, we have all sorts of projects that require moving, everything from dirt, facility construction. We're just building out a whole new supercomputing pad right now. There's been a whole lot of refurbishment down at Kennedy Space Center to get ready for the new, larger rockets. So pretty much any engineering discipline, we have people doing that somewhere at NASA. So pretty broad.
And so another question comes from Evil Mr. Muffins. That is an awesome name.
That's great.
What degree should I get to work at NASA? There's a big old smiley face. So I guess, if I went on the science side, Mary Beth, what would you, if people who are asking you, what should I study to get a job at NASA, what would you say?
Wow, yeah, there's a lot of options. I mean, I work with people who have degrees in physics, biology, chemistry, astronomy. I think the best course of action is just choose something you're super passionate about, because let me tell you, it's a lot of school. It's 10 years of school after high school to get to this point of being a scientist at NASA. You have to get your bachelor's in something and then your PhD. So if you don't really love what you're doing, it's a long haul.
Well, and I've found that it's there's a job for everybody. I mean, for me, I'm probably the one person at the table without a science degree, I'm guessing. And so, but my communications and poli-sci thing works out pretty well.
We still love you, Matt.
Yeah. I appreciate that. And on the future one, as we were assigning roles, I was sure to be put as the tourist.
Actually, I made you the pilot.
Really? Oh, nice.
But you've got a really good point. Right? It's not just on the engineering side. We employ all different shades and varieties of engineers, but across the board, right? NASA's a big, complicated organization that does lots of amazing stuff, and it takes a huge cast of supporting characters to make that all happen. So, hey, everybody from, the public safety guy, we've got, NASA has cops,
lawyers.
We have firefighters, we have lawyers, we have people doing procurement, literally every profession you can think of, we have people that are doing that.
I remember doing a podcast episode with somebody who had actually went through budgeting and procurement, but then eventually ended up doing a temporary assignment as a project manager, and then ended up doing more stuff and is on the technical side, but with it's like a whole mix, and you never know where you can end up. So Scott, tell us, what are we looking at? What have you been pulling together on this iPad over here?
Yeah, I've just been flying a spacecraft into orbit while you guys were talking about all that. So we flew, we built a spacecraft, we flew it into orbit. We are now actually in orbit. So this was a simple 2-stage rocket, and I built everything by dragging and dropping. And yeah, you fired the main engine to boost us up into a kind of suborbital trajectory, and then we circularized with this little engine. So we're now here, and honestly, we're just going to go back. Because this isn't...
What kind of altitude did you get there?
Well, this is a scaled down Earth. So our height is... We're reaching up to 173 kilometers, and that is not really to scale. But it's nice to have scaled down Earth, because it means your orbits are faster. So I'm just going to actually go back now. We're going to land this. So we're going to reduce the time warp, and then we're going to perform a retrograde burn to slow our orbit down and bring the periaps, or perigee, inside the atmosphere. So
explain, what is that?
The perigee is the point in the orbit which is closest to the planet Earth. You have the perigee and the apogee. So I'm at apogee, or it says apoapsis, which is the general version. Perigee is over here, and that is the closest point, and you'll see there, periapsis. G implies that it's Earth. So you'll also get like peri-Jove around Jupiter, which is Juno goes from its distant apogee to close peri-Jove. And with Parker Solar Probe, you're going to have perihelion when it's really close and getting very hot, and aphelion when it's a long way out. I'm just going to fire my engine, and the thrust is dropping my orbit down into the atmosphere, and we're then going to use that to descend and land.
Oh, nice.
So yeah, and then I just wanted to show this. This is space, I think a space flight simulator. It's free, and you get it on Android and everything, Mac OS, or not Mac, iOS. So if you've got a phone, if you're just interested in flying rockets, this is a fantastic option for you. There's some other ones I want to look at. So we're now falling through the atmosphere, and as we fall through the atmosphere, the drag is going to slow our orbit down. You can see down here that our apoapse is decreasing because the atmosphere is slowing us down, we're losing energy, and so our orbit is getting closer and closer to the planet, and eventually we're going to slow down and we'll have to use the parachute. But we don't want to use the parachute just yet.
Yeah.
Because it will tear off at this speed.
Right? Burn off. As
Burn
the case
off,
may be.
yes.
Yep.
You're going to have it. Well, the funny thing is, I think the first time for me playing Kerbal, I was messing around with it, just like trying to do a quick suborbital launch, but I got really high. And then as the rocket was going back in, I'm like, all right, I'm going to try to land this thing. And I got the hatch or whatever it is, and I had it pointing straight down, just steamrolling like right to planet Earth to go and land. And I started noticing the Kerbal was having a very bad time as it was getting redder and like beaming and I'm like, what is going on? Why is this not working? And I was like, I wasn't going that fast. I'm just falling. And then I remembered the conversation that I had with Jack Boyd, like on the podcast, of the whole blunt face idea.
Yes.
And I flipped it around, everything cooled off, and
Yeah, I am
Kerbal
actually
was much
having that
happier.
exact problem. I'm going nose first. Thankfully, this doesn't model re-entry heating, or I would have burned off my parachute and killed my crew. But we don't get to know the crew, so we can just treat them as faceless entities.
Well, it's a simulation.
It's a
right?
simulation, yes. It's very hard and
Well,
serious.
aside from the atmospheric heating, you're probably not stable going nose first. So
The cones are stable in both directions. On the Mercury, they had to have a little spoiler to flip it around if it came down the wrong way. I remember, yeah.
Well, I was gonna say, like, so for Chad, while you're sitting around in school, I mean,
We cannot
I
deploy
don't
a
know,
parachute.
these kind of simulations. Is that anything? I mean, when people are doing engineering school, does anything like this available?
Not when I went to school, Matt.
You have to do it on paper, right?
Not for young 25-year-old Chad Frost.
Yeah, we were lucky to have paper. We had stone slates and chalk. So one of the first pieces of code I had to write for my engineering software class was a three-body simulation of orbital dynamics. Right, so. Anyone could have, gone out and done a three-body simulation. It's not that hard, but boy, you sure learn a lot about orbital mechanics when you have to write the code yourself, right? It wasn't a sophisticated simulation, but there's no better way to learn the basics than to actually have to code it up. And now there's all sorts of great simulations and tools, I think are also really great ways to sort of learn what's going on, Perigee, apogee, what do these terms mean? Well, you could just look at that little simulation, and it's right there, and it's very instantly intuitive in ways that just reading it out of a book might not be.
Wow. Yeah, I mean, a lot of these stuff, even like terms like delta V, different things, like I'd heard people talk about it, but it wasn't until actually playing some of the games I'm like, oh, that's what they're talking about.
Start
Okay,
building
that makes more sense.
Visceral, intuitive sense, right? That engineering sense of what it really is.
Nice. So what are we looking at?
I've switched over to another one here. This is Simple Rockets, which is very similar. It's it's older. It has soft body physics. So when you build really big rockets, they can, you can have things break. But I was actually going to hand this over to Mary and see if she wants to try landing this.
And this is for folks, if you did not watch the previous episode of us doing Let's Play Space video games, Mary Beth landed the lunar lander the first time without any practicing whatsoever.
Completely
It tells you
nailed
to
it.
activate your landing legs.
Okay.
Yeah, there you go.
This is high pressure, man.
That's okay.
I'm a scientist, not an engineer.
Well, the game really provides these very helpful hints, like you're falling too fast.
Yeah, you've got more thrust, more thrust.
No. Oh no!
I bounced.
You saved it.
Wow, how did that
I
happen?
don't know, but I did it.
Yeah, you're now going to turn off your engines. You're
okay,
getting
okay,
higher.
okay.
You still have to land this thing.
I want to go back to space. What are you talking about?
No. Where are you going?
There's more science to find.
You
This is
pointed the
land-
wrong way. No. Oh.
You want me to the
I
other
think
way?
that was abort mode.
You turn off your engines. You're. There you go. Now you can point in that direction.
Well, one
So
of
you're
the-
250 meters up, and there you go. You're pointed the wrong way though. There. No, it's now catching up. There you go.
Well, one of the questions from the chat, this was from NoSync. He was asking, "Are you guys
thrust.
going back to the moon?" And it's like, yes. Here we are. Oh,
Okay,
You've landed twice already.
I know. I just love space so much.
Yes.
she just doesn't want it to end.
I don't want to
Yeah.
go home.
What? There. Land it.
Now, is this the moon or is this?
This is another version of the moon. Yes.
This would appear to be a rocky planet.
Yes, it has regolith.
Nice.
There you go. And
Well done.
All
a
of my
winner
friends.
is you.
I did it.
You have
Yes.
landed. This is not what happened while we were just messing around with this
I
earlier.
didn't know about the like secret magic powers of lunar landing. It's consistently every time.
Sign me up.
She is a part of the NASA Ames video game club.
I am.
But that's mainly like Mario Kart. So
I'm getting really good at it though.
nice.
Does anyone want to try docking a spacecraft? I guess we're actually we can't
How
pass it
far
any
can that
further.
cord go?
Yeah.
Gonna head on over to Chad?
I get it.
All right, we got this.
Uh,
All right, we'll hit up another one before we start moving
Yes.
along.
So
Well,
what do I
think
need to do here?
You got to try and dock with these two spacecraft. So it's you've got controls at the bottom there.
Well, let's figure out what the controls do first. So it looks
There.
like oh, that's
There you go.
interesting.
You
So
get
I have some
translate.
rotate.
There you go. So you can drag. Yep.
This is very realistic because there's no actual attitude control. It's entirely up to you.
See, now if I'm
That's
going
why
to
you
go
have a
into
computer.
to go full Twitch streamer mode, then I'd have Chad explain the model of Laddie while he's playing at the same time to see if he can do two things at once.
Figuring out just sort of how to control it seems to be the hardest part. So.
Yeah.
But
I'm
going-
not-
Super
Well, I was going to say,
intuitive.
going into one of the questions people were asking about going back to the moon. Obviously, we're playing around with like landing on the moon, and we have some other things in the store like that are moon focused. But just recently, and not the last episode, but the previous episode of NASA Silicon Valley Live, we had the administrator Jim Bridenstine on, and talked a lot about going to the moon. And more particularly talking about how it's not flags and footprints like last time. It's all about getting commercial partners together. Look at that. You bumped into
I
the
bumped
satellite.
Into the satellite.
Right. Ask you to. You can try again.
So, for folks who may be listening as the audio version of this podcast, this might be one. Maybe you're sitting in your car on the 101, sitting in traffic. This might be the episode for you to pause and actually wait till you get home, and so you can watch it, on demand on Twitch or on YouTube, because it might be a more visually.
I'm just wondering where the
Experience.
docking ports on this actually are. He might be.
It helps.
I think
if
they're on the
man.
side there.
How's that?
Yeah, they're between those solar panels. That's what you got
Oh,
to
they're over on the side. Oh, I better stop and back up.
Is that realistic?
What
Yeah,
engineer would
actually-
put docking ports there?
The problem is I can't fly over the solar arrays. I
Yes,
have
this
to-
is two-dimensional.
It appears like I have to go up.
I was going to say.
Yeah,
up
your
to the
space bus
side
has to
here.
slide around like that.
And the other thing that's
Now, we did have one other game, but I'm having trouble starting it with right now, and I'm not sure. Maybe we can try it towards the end, but...
Well, we're hitting it about about 15 minutes left.
Oh,
so
wow, we
we'll
better-
hop on over to the next one. Once we get Chad,
Let's see if we can do this.
you can do it, Chad. Everybody believes in you.
There we go. Just thread the needle here.
And then I'll just jump in. Another question from the chat. This is from Dat One Fish. Does studying in the field of aerospace engineering help in becoming an astronaut?
Yes.
It could, yes.
I would say absolutely yes. In fact,
Although it hasn't worked for me as an aerospace engineer, I'm not yet an astronaut, so no guarantees.
well, that was one I remember. So Steve Smith, he was he's our local astronaut that we always default to. He's from the Bay Area, and he had talked. He was an engineer and locally, and then eventually he took an engineering job at NASA Johnson. And I think he applied to the astronaut class like 4 or 5 times until he finally got in. So I was gonna say, if you're applying to be an astronaut,
Be persistent.
you have to be persistent because you never know.
Use the translate.
It's a little bump. It's still good. It's still good.
Hey, come back. Oh, now I got the satellite moving around.
Yeah. Now you're in a Salyut 7 situation.
You got
right?
this. Easy breezy.
Almost.
All right.
Yeah,
Well, that wasn't
you
great,
docked.
but
It's docked. It worked.
Fabulous.
wasn't pretty, but it was successful.
Yes,
So,
and you now have to repair the solar panels. But you're an engineer, so you can figure that out.
I'll take that one.
So for folks who are just jumping in, what we're going to do is we're going to transition to the next game, which basically means that Scott is going to unplug one HDMI cable and plug it into another PC.
Have a little PC here.
But for
Yeah, for
but for our
technology.
on the chat, if you are joining us live, you are watching us on twitch.tv/NASA. That is where you need to go in order to join the chat. Our friend Kayvon is he's actually moderating he's the NASA behind on the chat. So yeah, so go ahead, send in those questions. In fact, we may just jump in. Yeah, go to twitch.tv/NASA. I'm going to do a quick rapid fire as we get the next game all riled up. But also, in fact, even as we're doing this, I could do a shout out over to Bill and Dave over in the Bill and Dave cam. So, hey everybody.
Hey guys.
So,
Hey, Bill and Dave.
so Bill, Dave, it's like, do you guys have any questions for the group as we start getting things transitioned over about these games?
Well, no, not really, but I can come up with one. What I was just wondering is, how do game designers have to balance the fact of space exploration by nature is kind of boring because it takes so long and we can't go very fast versus all the entertainment value of things like hyperspace, things like, how do you think game designers come up with a good balance between making it fun and making it real?
Wow.
Yeah, I mean, games, they love to include time warp for all those boring things. So that you basically run time forward, so you don't have to spend a whole week traveling to the moon.
You may want to click on the space bar or maybe on the mouse.
Yeah, that's
'cause
what I've been trying. It's
we're trying to get the next game loaded
this,
up.
This thing is...
Is it
not-
hot?
But yeah, I mean, balancing game design is really, fascinating question as to how these things work. But with Kerbal, also, it helps that you have lots of explosions. So there's lots of moments of terror and fire, and then the rest of the time it's very slow and maybe trying to figure out your orbital rendezvous and very carefully put it together.
I think there's also this interesting balance between realism and playability, right? So you can have something that's really models the physics very authentically, but at the same time, if you make it too authentic, right? In the game I was just playing, if I had bumped my little spacecraft into the satellite, right, there would have been death and destruction all over the place.
Well, that happens in Kerbal Space Program if you did that.
And so there's this trade between, do I make it so authentic that it's unplayable, or do I back off a little bit on the authenticity and have enough realism but still make it kind of a fun to play game?
We should try
So-
Space Simulator instead.
I know. Well, what we're going to do, in fact, what I'm going to try and do, so Chad, I'm going to flip on over because this is the joy of being on live television on twitch.tv/NASA is that sometimes even when you have the game working for an hour plus before we went live, sometimes things tend to go wrong. And that's okay. So I'm going to hop on over to go see if I can get that thing up and running because it's actually my personal PC, which is for whatever reason
all Matt's fault.
the cable isn't working. I'm not sure if it's too hot or whatever. But I'm gonna turn it over to my friend Chad over here to look at this to look at the chat, and so we can just start rapid fire through some questions.
Okay.
So why don't you just go through here, and I'm gonna hop on over to see if I can help Scott over there.
All right, we're just going to go right down from the top, rapid fire. All right, can you explain Lagrange orbits? This is from Snackless Kerbal, who's, I guess he's hungry up in space. Sure. So Lagrange points are those interesting spots in our solar system where the gravitational attraction of different bodies cancel each other out. Right. So we have Lagrange points between the Earth and the Moon, between Earth and the Sun, where if you put a spacecraft at that point, it's sort of right in this nice little point of balance between them, and so you can't. They don't just sit there of their own accord. They typically have to be in sort of a little bit of a drift around that point to be stable. But let's just put some scientific spacecraft out there, and they don't have to use a lot of fuel to stay there, and they're not in an orbit around the Earth. They're nice and far away. They can do their science. Mary Beth, you got anything you want to add, or Scott?
I was thinking about like what are the cool missions or spacecraft that we have at Lagrange points right now. Like I know James Webb. Where's that one going? That's gonna be
James Webb is going
new-
out, and I can't
new
remember
space
which
telescope.
one exactly, but it's a common place to go park big experiments, things that need to be out there for a long time.
Yeah, and then you've also got Lucy, which
Lucy's
is
a
planning
good
to
one.
actually visit the Jovian Lagrange points, where you've got these asteroids, these very old asteroids that have been trapped there since the formation of the solar system. So headed out there to get a close look at these things.
Of course, one of the challenges, for example, with the James Webb Space Telescope is, it's a far distance out there. So once we send something there, we can't just, at this point, send astronauts out to go fix it if there's a problem. It really has to be pretty self-sufficient. Okay, next one on the list from Taz Ace. Can people live on the moon?
For how long is the real answer?
I think if you magically dropped somebody, teleported them onto the moon, they could live there for, a few
Seconds.
moments. It would be longer if they had a spacesuit. Longer yet if they had some protection from the radiation environment and the heat and the cold, so some sort of a habitat. So as long as we provide them with the necessary habitat, then sure, eventually we have to feed them. So they don't, snackless Kerbal may be hungry because we already gave the food to the people on
Snackless
the moon.
Kerbal's living on the moon.
Yeah.
Yes. Well, snacks are the fundamental unit of life support in the Kerbal universe. They don't run out of air, they run out of snacks.
Run out of snacks. Okay, looks like these guys have it running. We'll come back to the questions. Not yet?
Yeah, this is rebooting.
No.
So we
Okay.
are not quite there. What we're actually going to end up doing is hey Scott, how you doing?
Hey.
So what we're going to end up doing is it is booting up right now. So we're going to go do some more rapid fire before we go ahead and jump on in. So I'm going to hop over there.
I was thinking, yeah, okay. Well,
Or yeah, if you want to.
I'm just wondering if we unplug this, whether it'll break it or not.
Well, I think the thing is that we won't be able to get Steam up and running to get
Oh,
the
yes,
game going.
okay.
So let's just jump.
Let's
on
just
over.
keep on this. Let's keep answering questions.
Let's see, what's a good one here?
It decided to do a Windows update.
Really?
It's a Windows update. That's what happened.
It's so funny. This
Okay.
is like welcome to live television, folks.
Here's a good one for Mary Beth. Shade of Dead says, what about rain on Venus?
On Venus? Oh, I think it's too hot. What would be
You get
raining?
rain in the upper atmosphere, apparently,
Oh,
but it
really?
evaporates before it hits the surface.
Okay.
That's what I've seen some evidence of that. And I was watching an NIAC stream, and they were talking about a balloon that would look at this, and also considered looking at dust that would be blown up from the surface because of the very dense atmosphere. So.
I think also at this point, I don't think we know. There's hypotheses. We've talked about sending a new generation of probes to Venus at some point. It's been a long time since we sent any. Maybe that'd be a great question to try and seek answers to.
Yeah.
Let's see. So robotics. This is from Kinetic. So robotics will have to advance for us to advance in outer space. Yeah,
That's a question for you, Chen.
Yes, it
I
will.
think that's
Why-
perfect for you, Chen.
why,
It's more of a
yes.
statement of yes, indeed. Yes, it will.
I think
Now it's updating Steam, by the way.
we're going to send humans deeper into space, and we're going to send robots right alongside them. Right now, one of the NASA plans is to have a future, outpost in the vicinity of the moon, and we're not going to be able to have humans there full time. Humans might be there, a month out of the year. And so the question is, well, how do we take care of the place the other 11 months out of the year? So we really need to have some robots to help with that. We talked earlier about having robots help build the future things that we're going to have in space, like habitats and space stations. I think especially the further out into space we go, the more robotics we'll need, and the more autonomy we'll have to have as well.
So we are getting Steam booted up. The game is about to go. And ladies and gentlemen, my laptop just died, so we're going to keep doing some questions, but I'm going to do this from my mobile phone. But, okay.
Darn batteries.
Because it is live television, so it's going to be really fun. But let me jump on into the chat, which I have some stuff right here. Okay, what information can be gathered from the newly landed Japanese probes on Rygu?
They've obviously got cameras on there right now, but these people should appreciate these are just the first of many landers. There's going to be a second lander and a third, and they're also going to shoot it with an anti-tank round to make a hole in it so they can get a sample. The Ryugu asteroid, I'm fascinated by this because it's a very undifferentiated kind of rock, so it's going to give us some real interesting old look at the kind of pristine material from the solar system, early solar system.
I'm a big fan of the old school, if you want to know what it's made of and what its characteristics are, poke it with a stick.
Yep. So they're going to hit it hard, and then they're going to bring a sample from underneath the surface back home eventually.
So I'm also just kind of realizing how, like, a lot of the stuff that we worked on before we started, if the computer actually saved the game. Oh, you did save it.
Yes. We actually have Kerbal up now.
All right. So, spoiler, ladies and gentlemen, that our third and final game for the evening is going to be an encore presentation of Kerbal. Jesse, I'm good.
And we think we have like 3 minutes left
Kerbal
on the
Space.
clock.
So this is what we're going to basically end up doing, because we normally go for about an hour, and so let's throw it up to the chat. We got about like 2 minutes. I think we're just going to go for another half hour.
Oh my goodness!
And let's just keep the party going, and we're going to get Kerbal up and running. And so we have that going on behind us right now.
Yeah, so I know you mentioned that NASA doesn't necessarily endorse anything, but they did actually work with the developers.
There was actually a Space Act agreement where they put in special content in it.
And they added the parts to make the SLS in Kerbal Space Program. And this was a slightly older version of the SLS with different paintwork. So it doesn't have the sweeps or whatever on the external boosters. But I built up something that's pretty close to
it looks about right.
a Block 1, roughly. It's obviously Kerbal scaled, but it has a crew of 3. We have an Orion spacecraft at the top. This is a hypergolic upper stage. So wait a second, that's not the... I'm missing a stage here.
Oh no, did we miss a stage?
I'm missing a stage.
You gotta check your staging.
I gotta check my staging.
As it says on your t-shirt. Sorry for folk audio listeners.
Yes. Because yes, the upper stage on the Block 1 is going to use 4 RL-10 engines, and then it's going to use an AJ-10 hypergolic engine on the final stage. But the main stage is going to be powered by liquid hydrogen and oxygen and 4 of these RS-25 engines, which were the same engines that powered the space shuttle.
Those things are absolutely impressively enormous. I was out there standing next to one of those not long ago, and I didn't fully appreciate just how huge they were until I was standing right next to one of them, and it just kind of was looking up just at the engine. It's like, oh my goodness, that's just huge.
Oh, wow.
Yeah, the RS-25 engines are still right up there as some of the best engines ever developed. Everybody's, in terms of specific impulse, they're way up there. And newer engines are switching over to different fuel cycles, but they're not going to get the same efficiency.
And so basically what we're trying to do here, this is SLS EM1 is what I always hear referred to.
Yes.
So why don't you guys explain to me, what is EM1 for us, for the noobs? What is that?
So
what does that mean? What is that?
EM1 is the upcoming sort of test mission to take the system out around the moon and back, right? So EM1 is the first one that will take the complete system up and out and around the moon and back. Won't have any crew on board. Have a whole bunch of experiments. The SLS is carrying along with it, in addition to the Orion on the top, it's actually carrying along a whole bunch of additional CubeSats around the interim cryogenic propulsion stage, the ICPS. It's sort of that big conical ring down there. And on its way out, it'll deploy a whole bunch of those little secondary spacecraft too. So it's doing a whole bunch of interesting things on that mission.
So we see those boosters just fell off?
Yep. And
well,
then we're
deployed,
on...
I guess, or...
Yeah, we don't say fell off.
They didn't really just fall off.
We
What is the
staged
proper?
them.
Is it launching from Cape Canaveral?
No, it's launching from Kerbal Space Center.
Yeah, because I don't remember that many
KSC.
mountains in.
It is KSC, though.
There's
Okay.
not many mountains
There's
in...
not many mountains in Florida.
No. But yeah.
And there's no boats out there.
There's
Can't
no boats
scrub
out
it-
there.
scrub
But there
your
is
launch.
Yeah, there are some islands that you can land on. So this is one of the great things about Kerbal Space Program is it's been around for like 8 years now, and I mentioned that people that have played this game are actually now working at NASA. Like it's changed people's views and turned them into actual rocket scientists. But the great thing about Kerbal Space Program is it is essentially simulating these rockets as multiple parts. I'm going to just throttle down my main engine. So I guess we're going to carry our main stage because we're going to go out to the moon. So right now we're just kind of holding attitude.
I was gonna say, like related to what you were just talking about. I recently had gone through like a training over at Wallops, and there was a couple people from Marshall, and they had seen the previous episode where we were doing Kerbal Space Program, and they were quite they were very adamant that you really need to get some people from the Marshall Space Flight Center onto the show to play some Kerbal, because there's a lot of Kerbal fans over at Marshall.
Those guys know way more about rockets than we do. We are not rocket folks here.
No, not at all.
If we need to know about rockets, we go ask them.
That is
Those
awesome.
guys are the experts.
Well, yeah, I mean, so Kerbal uses a slightly smaller version of reality. That everything is scaled down by a factor of 10, and that makes it kind of easier for the players because they have to spend less time trying to chase down targets for docking and everything. Space is big, and if you make it smaller, it makes things easier. But, physics-wise, the game engine models the thrust from the rockets, the aerodynamics, the thermal transfer, power flow. You get it all in there. And it kind of the natural behavior of aircraft and rockets all just comes out of modeling it like this. You can even have your rockets disintegrate at max Q because you overstress the airframe. It has the great thing is you play this game and there'll be a failure and your rocket explodes. And you can typically think back to some point in the past where a real rocket did exactly the same thing for the same reason. So I'm just putting ourselves into orbit. I think I'm gonna try going out to the moon right now, or we could, go somewhere else. We have a pretty big rocket here. I think I gave it way more fuel than we needed. We actually carried the entire first stage into orbit.
You brought the first stage.
And we still have fuel in it, so we might as well use that.
Let's go somewhere.
We're going to head out to the moon here. So to travel to the moon, we have to perform what's called a translunar injection in this case.
Okay.
And
What exactly does that
This is a
mean?
TMI.
Yes, TMI. So what you can actually do is use the navigation computer. You click on the orbit to create what's called a maneuver node, and then you say, at this maneuver, I want to add some thrust, and you can see that it's showing you after this maneuver that my orbit will go up. So we want this orbit to go up towards the moon, and I've carefully placed this node so that it should put me near the moon, you see, and it's actually telling me...
Because it's going to actually be moving while you're trying to get it, so you're trying to anticipate its space.
Yes, there we go. We're actually going to get an encounter with the moon there and then get kicked off into a slightly different orbit. But I think we can...
I think we could, well, as we're on our way over to the moon, we'll throw that over to the chat, and Kayvon will let me know, do you guys want to do we want to go to the moon, land, or circle around and come back? Or do we want to go somewhere else? So go ahead and jump into the chat and let us know what you want to do.
Yeah, I'm gonna take this. Do this. Oh, I'm just gonna use time acceleration to get here. So warp to next maneuver. Yes.
And so, so Mary Beth, as a scientist, it's like coming up with experiments and looking at like astrobiology. It's kind of, I don't know, how much time do you guys spent thinking about this kind of stuff of just like getting into orbit, and or is it just like this is the engineer's world, or how often do you guys like work together? I don't know.
I mean, it's really important to understand, how the engineering is going to impact whatever instrument payload you're developing. And so it's important, especially even early on, to start to think about those types of problems so you can make sure that whatever experiment you're trying to do, no part of launch or getting into space will affect that experiment. So
I also often think of, there's people here at Ames who are creating like experiments,
right?
And they're putting them together in this nice little box that they send over and get launched in a rocket. And I'm like, your experiment,
not a gentle activity.
Exactly. It's like surviving like a launch is a pretty traumatic thing for whatever is in that experiment and in that box. So.
Yeah, I've seen the test rigs that they use for all this, and it's vibration, heat, the electrical interference is
Acoustics.
Acoustics.
Thermal vac cycling. It's pretty brutal. One of my good friends works over at Goddard, and they have this beautiful, like, I don't even know how to describe it. It's like where all the spacecraft get born and tested, and like the size of the thermal vac chambers is huge, and my friend gives us like this excellent tour, and at the end of the tour, she takes you like downstairs into the basement where they have seamstresses who actually like sew to get, like, they cut out and sew together the spacecraft blankets, like the things that
The MLI, the multi-layer
so
insulation.
cool.
Yeah.
But like you think that you were at like a fabric store, like nope, you're like using this amazing material that helped like insulate it. And she's a thermal engineer, so she really cares about that stage. So
That stuff's hard to sew. I tried it once.
Really? You
Yeah, it's
did?
basically a bunch of layers of super, super, super thin, kind of like Mylar.
Yep.
Right? It's slippery, it's crinkly. You try and sew it. You can't do it on a sewing machine. At least I couldn't.
So something from the chat, we have Dialar42 is saying, send Chad on a spacewalk. Is this something we can do en route to the
Yeah,
moon?
we could do. Yeah, I mean, they did that with Apollo. On the way back, they had to go on a spacewalk to recover one of the cameras. I'm just putting this into I'm putting this into an orbit that will swing over the North Pole of the moon here. So, en route. Yeah, let's get out for a little spacewalk here. Is that Chad? That's Chad. There we go.
We have the
EVA.
picture is right over.
There we go. There's Chad, and I guess I'm just gonna. You're just gonna let go, and
Hey, way to go, Chad.
live your dream.
You're
Chad.
doing great.
Do I have a tether?
no, but you do have a
You look kind
jetpack,
of green.
so you can fly around. And look,
okay.
you're super excited.
As long as I have a jetpack, I'm good.
Yeah, you're good. There, look, we can see the rocket with all
Oh,
this.
wow.
We still have fuel in that main tank. I think I haven't really spec'd this up. I put this together very quickly, but with this game, I mean, I told you how they scaled everything down by a factor of 10.
Yeah.
Well, you can actually mod the game up to make it 100% realistic and try to replicate real spacecraft.
So as Chad's doing a spacewalk, I'm going to keep jumping into the chat because there's a whole bunch of questions in here. This kind of
I'm looking happier now, but
you're
still,
having a good time.
still kind of green.
Kerbal Chad is
Gotta get
super
some-
happy
gotta
right
get
now.
some Dramamine in there.
Exactly. Yes.
Yeah.
So one of the questions from the chat, this is from Seriously Gaming, asks, what are the opinions of gravitational waves? Are you all excited for gravitational astronomy? I don't know, that might be a little bit out of...
I'm very excited. I mean, University of Glasgow, where my alma mater, they did a lot of this work on this, and it's really fascinating to see the stuff that was talked about, when I was at university 20 years ago, finally working, finally showing off, finally getting results.
For Chad, Mary, that's fall into your world? Because the funny thing about at Ames is there's a little bit of everything. So we have astrobiology next to the supercomputing, next to the aeronautics, next to engineering and small sats. So there's a whole mismatch of disciplines at this center. So, but I don't know, do you guys interact with that as much, or?
Not really. It's
Yeah,
Or
not so-
happy hour at the space bar.
Happy hour's about it. The one thing I was thinking about in terms of gravitational waves, right, is so one of the things we do here at Ames is especially small spacecraft or missions with lots of small spacecraft, and there's the potential to do some really fascinating science with these littler spacecraft, but it depends on having really small compact instruments as well. And we were talking to some colleagues at one of the other government agencies about really, really tiny, highly sensitive magnetometers. And,
Okay.
and I had the thought, well, I wonder if you could put those in a small spacecraft and use that to do some research in the gravitational wave area. I don't know the answer. I'm not the scientist to answer the question, but
I know a guy.
But I know a guy, and it really intrigued me as to the possibilities. We're embarking into this whole new age and new era of being able to kind of go down this new path of research, and we don't yet know how to do some of it. So it's exciting.
And so it also that came up in the chat, one of the comments has been, let's go to the moon or Mars. And since the name of the game has been Moon to Mars, but speaking of which, the moon, we have this Laddie model sitting right in front.
We do.
Maybe you could talk a little bit about what the Laddie model is, what Laddie did, and even Mary Beth, it's the moon is still ripe for science. there's a lot of stuff that I mean, you think what it was in the 70s was the last time we actually had footprints on the moon. But since then, we learned a whole lot more about like how much water ice is there. It's just quite crazy. So I don't know. Like, the delicate model that I tried to move earlier.
It's not that delicate. It's pretty robust.
I went to grab
it. You picked it up and it came
I was like,
right, but it's supposed to come apart, Matt. So I figured we're talking about spacecraft. It's always good to have a toy to sort of illustrate questions as they come up. And this happens to be a model of our Laddie spacecraft that went and orbited the moon lots and lots and lots of times a few years ago, doing amazing science, and now is in many tiny little pieces on the surface because at the end of its mission, we just crashed it into the surface, carefully avoiding any historical artifacts. But so Laddie is a good example of what you can do with a comparatively low-cost spacecraft. Right, this is something not to actual size, but it is to scale. This was about the size of a refrigerator, right? A good-sized refrigerator. Right, and it was designed as a modular spacecraft. So as different missions came along, we could reconfigure it to the needs of the mission. Right, you might not need all these different pieces. You might just need the top piece and one of the bottom pieces, right, with the propulsion, depending on what you were doing. And we designed a version of this that was a little bit bigger. It had 2 more of these middle segments that could do a Mars mission, for example, right, and the cool thing is, right, we can now do all this amazing science with smaller spacecraft because our ability to squeeze the science into smaller, more compact, and more efficient instruments has allowed us to do more with smaller spacecraft. So it opens up all these new opportunities for folks like Mary Beth.
Yeah.
We're like, okay, we can actually go do some amazing stuff with little tiny spacecraft now. JPL has the 2 Marco CubeSats, right? They're the size of a briefcase, and they're on their way out to support the latest Mars mission. So there's just so much potential, and it's enabled in part by technology, in part by new ways of thinking about science.
So I see that we're from behind us. We are at the moon right now.
Yeah,
but
I'm trying to. We have a lunar gateway in orbit around the moon. I figured let's go and visit it.
Might as well.
So we're going slightly further than what EM1 has because somebody's got a space station there already.
Oh, nice.
So I'm just trying to match orbital planes with it so we can perform this rendezvous. And actually, that's pushed me out of the sphere of influence. We'll figure this out.
And while you're figuring that out, Mary Beth, why don't you talk a little bit about? I mean, what about the moon that you see like interesting, or as a planetary scientist?
Yeah, there's so many interesting things about the moon that we're still learning. I think the most interesting thing about the moon is that it came from Earth, right? Like it was formed by very early on in Earth's history by an object that was believed to be about the size of Mars, impacting the proto-Earth and then turning into this object, right? And I think about this oftentimes from an astrobiological perspective. It's like what is so special about Earth to allow life to develop and evolve? And I think the moon is a big part of that story, because if you look at the far side of the moon, it's littered with craters. And so what does that mean? It means that things that would have, if there was no moon, would have impacted Earth and instead hit the moon and maybe protected, early life on Earth and allowed it to continue to evolve. But I think one of the coolest discoveries in the last 10 years was a mission that was out of Ames called LCROSS. And what happened with LCROSS is they took the upper stage of a rocket and they actually impacted one of the so-called permanently shadowed craters on the moon, and within those craters they actually found evidence for water. And so why do we care about that? Especially if we start thinking about going and living on the moon, that's a resource that could be potentially used in situ. So I thought that was a pretty cool design for a mission. They didn't land anything, they just impacted, kicked up a bunch of dust, and then analyzed and flew through the dust. I think that's a really cool design.
I mean, one of the big questions now for our return to the moon is, what's the distribution of the various materials present on the surface of the moon, right? So, okay, we know there's water. Now we know that there's actually quite a bit of ice not buried necessarily, but near or on the surface, especially in some of these shadowed craters. Okay, well, where is it? How much is there? How do we get it? What do we do with it? They're all really important questions that need to be answered if we want to have any sort of a presence there.
Like a long-term presence.
Long-term presence
like
on the moon.
During the Apollo era, we went and we were tourists, we were visitors, but we didn't stay for very long.
We've learned so much since those initial flags and footprints. Well, even just one thing that I think of is like a lot of precious earth metals, which really aren't earth metals. They came in asteroids and they're like formed in the solar system and impacted and hit Earth. But I mean, there's a lot of craters on the moon. There could be a chance that there's precious earth metals or moon or
Yes, but
asteroid.
it would never be profitable to get there.
Yeah.
The thing about metals and asteroids is that on the Earth you have metals that love to dissolve in iron and then they just sink to the core. So all our gold and platinum, it's all in the core. Whereas on asteroids, well, we've broke those planets apart, and we can actually get bits of the cores of protoplanets. That's why asteroid mining has these bits of metal, these huge amounts of metal in them.
So I see that we're getting a little bit closer on Kerbal, but there was a question that came in for Scott that was like, could you please ask Scott about the KSP Kraken?
The Kraken. Yes, the Kraken is a fantastic result of game proing. Yes. So the Kraken is what happens when physics goes wrong. So
okay,
it's kind of fascinating. Sometimes there's a physics engine in the game that's modeling how it works, how the physics and everything works. And sometimes it has mathematical errors which can cause the spacecraft to disintegrate. So in the old days, when you got very, very fast and very, very close to the sun, the spacecraft would just spin out of control and disintegrate. And we called that the Kraken. And the developers have slowly fixed these things bit by bit, but every now and then you will just find the most bizarre bug where your spacecraft just spontaneously explodes, or you hit some weird singularity in the mathematics and everything disintegrates. And then people have learned to harness the Kraken for good, and they've learned to build Kraken drives, reactionless thrusters that don't need fuel. So, yeah, the Kraken is a great friend and enemy in the game, and is actually out on one of the moons. There's a Kraken corpse available that you can find if you're sufficiently interested.
So there's another thing from the chat, another question. This is from Fox_Tango, which, welcome back. I remember Fox Tango has been there quite a bit. So in previous episodes, but have any samples, piezoelectric stone, been collected from the moon, Mars, or other astral body? I'm probably butchering the name. People are looking at me and shaking their heads.
Well, I'm trying the materials that came back from the moon that have been analyzed. I don't recall them having any piezoelectric or semiconductor properties, but I'm not a material scientist, so I could be wrong.
What is piezoelectric? The word that I butchered, what does that mean?
So if you have a material that you impose stress on, right, it produces voltage.
Okay.
Right? And vice versa, you can apply voltage and it'll displace the material. So
some just like metals, or
for example, some of the materials in your microphone might be a piezoelectric microphone. Certainly, probably the one in your phone is.
Yeah.
Right. So it's converting the pressure from the sound waves in your voice into an electrical signal.
Oh,
right?
interesting.
So
okay.
materials that do that, right? A family of those materials it's a piezoelectric effect.
The more you know.
So the short answer to their question, right?
Yes, is no.
We don't know.
We don't know.
We don't recall any of that coming in, but that doesn't mean it hasn't.
Yeah.
But they're very easy to make. I mean, they're pretty much very simple industrial. I mean, they're types of quartz with doping.
Yeah, it's everywhere.
So all right, are we at the moon? Are we landing on the moon? What
we're just orbiting. Oh, apparently we now want to use sticky keys.
I'm gonna say.
I was trying to rendezvous, but it's actually very hard because
you have to minimize big picture mode.
Minimize big picture. Yeah. Okay.
And then we get
there's
this. My desktop.
It's a good thing I wasn't trying to land at that time.
If you can't tell, ladies and gentlemen, this is not Scott's normal PC.
Yeah.
He is fiddling around with.
I'm actually having some interesting problems here because I can't see the orbit as easily as I normally would. So I think. Yeah, I'm just trying to figure out how to make this rendezvous here. But you go on. Go talk.
So, well, there's Payson Canut 42 was saying, do a suicide burn landing on the moon, please.
Okay, well, never. Right, let's just try landing this. Everybody wants to see me try a landing, right?
Why not? So let me jump to another question from Alpha King Gore. How big a problem is space debris? Let me just throw that up to everybody for what you think.
Well, at the moment, it's a problem, but it's not a gigantic problem.
Right now.
It's in the news frequently these days because it has the potential to become a huge problem. Right? So right now, there's plenty of space debris up there. There's spent rocket bodies, there's dead satellites, there's little bits of nuts and bolts and junk that's blown up over the years. There's a whole big cloud of debris from satellites that have collided. The good news is, right, most of it is not where we have people, right? For example, on the space station. And most of it is not where it's going to run into other satellites at the moment, right? We do occasionally have to move satellites to get out of the way of space debris as it's floating around. However, right, with all the spacecraft that are being launched, and there's more and more spacecraft being launched all the time, all it would take is a couple of bad days for there suddenly to be a whole lot of space debris in a bad place. Right, so the potential for there to be a really big space debris problem is very high.
So let me jump into one more. Are we ready to land? Are we getting there?
Well, we're gonna.
I got a fun Mars one, and I know Mary Beth, Mars is her favorite subject.
I'm a Martian.
Yes, she's very much the Martian. If folks didn't know, you co-authored the paper for when they discovered liquid water on Mars. Whatever, just kind of dust it off. I like to.
Matt likes to embarrass me.
I always like to call out to Mary Beth, she's like, yeah, whatever, But okay, here's a question from
just a side project.
Nuranon, who's asking what to do about perchloride on Mars when crews visit.
When crews visit, yeah. So perchlorate is a salt, and it's found on Earth. It actually comprises rocket fuel too. And it accumulates in extremely dry places. So it's a problem in a lot of desert environments, including in Southern California, for example. And it's toxic to humans. So if you consume perchlorate, because it's so soluble, meaning it goes into water very easily, and you drink that water, it can cause thyroid issues. And actually, I think it used to be used as a treatment for overactive thyroids, back in the day.
Okay.
Anyway, so there's a ton of perchlorate on Mars, and that ties into the whole water on Mars story, because what we detected was actually hydrated perchlorates, so water bands that, or water within the mineral structure of perchlorates. So anyway, if we end up using any resources there on Mars someday, perchlorate remediation might be an issue, depending on, how and what we use that type of water for.
So Mark Watney's going to have a hard time growing his potatoes.
Well, he might have a hard time having a thyroid.
If you had hypothyroidism, he's going to have a hard time.
But, there are chemical solutions to this, and I'm sure we could figure out a way to remove it if we needed to. But it also gets in the way, just from a science perspective, when we're doing analyses of the soils, it can actually react with some of the carbon-bearing compounds in the soil, and turn into a big chemistry reaction. So it's been problematic for previous Mars missions looking for organic compounds. So
as we're looking on the screen right now, what do you have going for us, Scott?
I think we decided to break with the actual mission plan, and we're just going to land. We're going to land this using its...
we just left all that extra fuel out there. We figured, you know what? Let's just jump.
Actually, we finally depleted that big tank. So I think
really?
I'm going to aim between these craters here.
So does this little version of the Orion, does this have some landing gear?
No, we're just going to land it on the engine
okay.
bells. Yeah.
Just checking.
Yeah. We do have solar panels. We should probably open those up just so we can get some electrical power.
Nice. Does it just give you more thrust? Or,
No,
or
we don't want to run out of electrical power when we're trying to land, do we?
I think that would be bad.
Yeah. So we're just going to put it down between these craters, and hopefully we won't fall over. This is a standard Kerbal maneuver, landing on the engine bells. Do not do it in a real rocket because engine
gonna have a
bells
bad
tend...
time.
You will crush them.
You will crush them. Yeah, even on one of the Apollo missions, they came down too close to the surface, and the engine bell got sort of crushed just by the force of the rocket exhaust. There's a famous photo of it being with a fold in it. And that wasn't because it hit the surface, it's just because the rocket exhaust bounced off and came back like a sound wave.
I'd like to point out that those solar arrays are a little dinky.
They are, but we're very efficient in the Kerbal universe.
Solar array.
Now, one thing I'm not sure of here is I can't see. I don't have an altitude meter. There we go.
Oh, there you go.
So
visual approach.
Yes,
He's
visual
gonna
approach in
land.
Kerbal.
Oh, look at
is,
that. Here we go. Oh, good
There
job.
we go. Okay, yes, we did it, and
Well
we can all
done.
EVA. I'll just get you off there.
Look, Chad, you're going to the moon
Oh,
now.
Chad, look at that.
Chat.
I always wanted to go to the moon.
Yep, you're on the moon. We're just gonna let
Where's
you.
the cheese?
Though, as we learned from the first episode that we did, 4 weeks ago with Administrator Jim Bridenstine, we learned that the moon was made of spare ribs.
Spare ribs.
Barbecue spare ribs, evidently.
Wow,
And,
I would
a lot
totally
for
trust
commercial
that.
crew, for commercial use, I'm sure.
The moon has many great things for it, but I don't think cheese or spare ribs. No.
Cheese or spare ribs.
A veritable cornucopia.
Although I do like to point out it's harder to prove that the moon isn't made of cheese than it is to prove that the Earth isn't flat.
Nice.
So why is there no Moon Cheese Society?
No Moon Cheese Society, exactly.
Perhaps there is.
And they could be rating every single Twitch stream, every single NASA stream or social media platform with the moon cheese or like truthers.
We should plant a flag here. There, I claim this moon in the name of. We got to come up with a message for all
Oh, hey,
humanity.
it's me. I'm on the moon too.
Yes, I think that's yours.
Yep.
Hey,
was I
Mary
the first
Beth,
one
what are
out?
you going to tell the world?
You have landed on the moon. What are you looking for? What's the first thing you do? You've landed on the moon. Where are you
Okay,
going?
I gotta quote Pete Conrad and
Okay.
say that may have been one small step for Neil, but that was one long one for me.
Yes.
Nice. So we're counting down to about like 2 minutes until we wrap up. So I'm wondering if we could probably do another rapid fire one. We have some. Okay, if bigger rockets increase efficiency for launching experiments, why don't we launch even bigger rockets? This is asked by Frank, a 5th grader from Resonator Games.
Because building bigger rocket engines is actually harder than you'd imagine. That's why the F1 engines are probably the biggest rocket engines that have ever been built due to combustion instability and things like that.
Yeah, I don't know that building bigger necessarily buys you more efficiency, right? In the case of SLS, it's bigger because we've got some pretty big, massive stuff that we want to send fairly far out beyond Earth orbit. At the same time, NASA's building the big SLS. We have a bunch of commercial companies that are building really small launch vehicles to send really small things into Earth orbit. And so we're looking forward to the day when we're just sending little tiny things up on little tiny rockets all the time. But those rockets aren't going to be sending things out to the moon. So there's a happy mix of the great big rockets to send big things really far out, and little tiny rockets sending little tiny things into the vicinity of the Earth.
So that, folks, is about all the time that we have. As you can look from behind us, Chad and Mary Beth are going to continue their EVA out on the moon. Just as a reminder, this has been NASA in Silicon Valley Live. This is a conversational show where we talk out of the Ames Research Center, where we talk to the scientists, researchers, engineers, and overall cool people here at NASA. If you like that, then we are live on Twitch, on YouTube, Facebook, Periscope. To join us live, you have to jump into twitch.tv/NASA. But if you can't catch us live, that's totally cool. On Twitch and YouTube, you can catch us on demand immediately after this broadcast is over. And it'll also be up on NASA TV as a rebroadcast, I think about next week, along with an audio version of the podcast. But I want to give a great thanks to all of our guests, to Scott, Mary Beth, and Chad. And a huge thank you to everybody in the chat. Thank you so much for joining us. And don't forget to join us back here in 2 weeks when we talk about NASA's 60th anniversary. But thanks for joining us.